Hi, this is Margo. This is Wednesday, July 17th, 2019, and I have with me on the line here today Robin Westenra from New Zealand, and we're going to be looking at Arctic sea ice, and it's our first time together for this season to be doing this and presenting our material to you. Hi, Robin. How are you doing today?
I'm doing fine.
It took us a while to get here.
Thank
We
you.
had
It's been a wee while.
quite an
Yeah,
a lot of interference at the beginning, but
none of the things uh, happen easily. Making movies to whatever it is, there's lots of interference.
it's getting harder all the time, and it's hard to tell whether it's AI bots or just censorship or whatever, but it's just getting harder all the time. So thank you for being here today. And if all goes well, then we'll plan on doing some more of these as so that we can track the sea ice. And it's going to be a monumental melt season, it looks like. What do you think?
Oh yeah, I listened to that chap, I can't, Comrades, and he actually did quite a good presentation, and I got
Yeah.
quite a lot out of it. And then what happened was, I really kind of got what he said that anything from less than 80 degrees north would be gone, and maybe the central region would be gone. But then yesterday I went looking, and it was the first sort of relatively clear day that we had seen, and I kept on seeing all these areas, within the 80-degree latitude, that are breaking up. And I can see one right now that I identified yesterday, and it's showing up
Hmm.
here on your picture
Yeah.
from we analyze. You can see it. It's
Yeah.
just just to the north of not of
Right.
Novaya Zemlya. I think
Yeah.
it's called uh, Severnaya Zemlya.
Oh, yeah.
That
Right up
yeah,
there. Yeah.
just a
Yeah,
little spot.
it's breaking up so fast and it's shocking, and you can see, like, if I go 10 days or, a week to 10 days between reports, it's really shocking to see the difference. So I've got some slides, I've got some pictures ready to show people so that they can see what we're looking at here. Now, this is from Climate Reanalyzer from today. This is sea ice and snow cover. And so we can see a dark line going from the East Siberia, looks like the Chukchi Sea, all the way down towards Canada on the west side of the North Pole. Do you see that dark line?
Oh yeah.
That's breaking up. And what I thought I'd do was just go backwards. I've got from June, I think it's July 1st through here. So I thought I'd just go backwards on this slideshow so we can see where we've been. And you can see how much is changing from day to day. Here's the 16th. This was yesterday. So that was when you did your report. Here's the 15th. Look at that big hole that opened up
Yeah,
on
yeah,
the wet. You see that?
yeah,
And it moves around. You see how that hole moves around from day to day? That's because the ice is so thin. And when they have rain or wind or um, any kind of ocean movement, it just moves that ice around and opens up holes. And that's how you can have a hole one day and then it can close back up the next day. So we're going back. Here's July 7th, 6th. So you can see a big difference already. Um, and here it
oh
is on
yeah,
the, isn't that
yeah.
something? Yeah.
That's
So,
amazing.
so I'll go back through. So that was July 1st, and then you can see it melting incrementally day by day. And it's been raining a lot up there. And with the sulfur dioxide that's in the atmosphere up there, of course, it's acid rain coming down and eating up the ice even faster. So here we are from today.
Yeah, yeah.
Okay, I've got some more pictures ready. Now the Navy. This is the Navy GIF. This is from today, and it goes back 3 weeks and forward 1 week. So you're familiar with all of this.
Oh, yeah.
That's just pathetic looking. It's so thin and it's melting so fast, and there's no old ice. And look, by the end of this forecast period right here, you know what? There's only 15 here. So it's,
Mm.
anyway, I downloaded it from their thing today. So it goes for, this is to July 24th. And look, so a week out, this is what they're
Yeah.
expecting the sea ice to look like a week out.
So that's showing really that the thickest ice, where we've had this sort of thick multi-year ice is now at the
Hmm.
most meters thick.
Hmm. And it's getting, and it's not even really aqua. It's that dark aqua blue, which is even
Yeah.
thinner. That's like 1.5 meters thick. So it's pathetic. And then the purple and the lavender is so thin. It's one to half a meter to less. And then the next picture, here it is from today. And we're going to look at NASA Worldview too in a minute here. And then I made this movie.
Yeah.
You see that? This is from July 1st. I made this movie today, and it goes through the 15th. Their Arctic sea ice, it takes them a couple of days to get the model up for Arctic sea ice, so that's why it only goes through the 15th. But you can see it with the blue. This is the concentration, the lack of
Oh,
concentration. The bluer it is, the thinner it is. That's
and
so,
Margo, it would be interesting if we've got it to look at the sea surface salinity,
yeah, we can do that. We
because there'll
can,
be a lot
mhm,
of
a lot of salt water coming in from the oceans there. Okay, so that's what we've got for her pictures that I prepared for everybody. So let's go. I'm going to stop that screen share, and now I'm going to open up a browser, and I'm going to get the browser shared. Okay, I need to find the right screen. Uh-oh, Robin, it looks like Robin is not here anymore. Um, okay, we're having so many problems. Let me start this other screen share application window. Here we go. All right. Um, we're going to look at methane in a minute. Here's NASA Worldview, and that's where I made the movie. So I'm going to turn off the blue marble layer and turn off that and hide that. Here it is from today. And so I'll just wait until Robin comes back on. Hold on a second. just go ahead and do the show. Robin is messaging me saying he lost connection and they're asking him to use the phone. And the phone is not going to be any good. So we're having a lot of interference here. We were hoping to do a conversation together, but we're having interference. So I'm going to go ahead and do the rest of the show here. So, we'll have to figure out something different next time, and we'll have to practice. So in the meantime, I have Worldview up, and I'm going to check on TalkShoe and make sure that that's up. Okay, so it looks like, I guess I'm up. I can't see it, so I'll go ahead and record it as if I'm up. So what we're looking at is NASA Worldview from today, and I'll refresh so that we can get the latest data. And I'll go ahead and do a zoom in, and we'll do a tour of the Arctic. And we've got a lot of clouds here today, it looks like. And here's Greenland. We can see we can see where it's melted around the north coast of Greenland here. And here's Svalbard, and we've got just a lot of clouds here today. Here's Novaya Zemlya, and it's covered with clouds. And there's the Yamal Peninsula. We can see ice-free all along the coastline, and we saw that in the Navy model that there's no ice right along these coastlines now, and it's without the clouds you would be able to see. Here's the Bering Strait, and it's totally ice-free, and the Beaufort Sea, it's ice-free along the coastline, and a lot of these tributaries have already melted. Here it is. Here's the Baffin Bay, west of Greenland. That's all melted, and this is the nearest strait, and that's melting very quickly as well. And so that's what it looks like right now in the Arctic. And we can see this line of the sea ice, the edge of the sea ice here on the right edge, or the east edge, because there's no clouds there. But we'd have to go back through some other days to see when there are no clouds. And, it's just a day-by-day thing. And it's been raining up there. Let's look at this is the Navy website. This is the sea surface salinity, the SSS, and this tells how much salt water is like the mixture, and when it's up into the reds, it's really high in salt concentration. And so we can see where it's coming in from the Atlantic, it's very high in salt concentration. And so the more salt there is, the faster that sea ice is going to melt, because it gets up underneath the ice, and it's warmer, and it eats it away. And then from the Pacific, we have a certain amount of salt water coming in too, but not as much, because that Bering Strait is more narrow. So we can look at 30 days GIF on that. That's I don't see much difference. That's just kind of holding. Hang on, Robin is messaging me again. Okay, so if we look at Climate Reanalyzer, here's what we've got for today. Maximum temperatures we can see in the Arctic. Most of it is above freezing. We've got a little bit of aqua over here. Here's your 2-meter temperature anomaly. And so we've got some brown, which means it's higher up here. Are you back on, Robin? Okay.
Yeah, I am actually.
Can you hear me?
Yes, I can.
Okay, can you see? I've got 2-meter temperature anomaly up.
Yeah,
Can you
no,
see that?
I can see all of that perfectly clearly.
Okay, so I'm just going through Climate Reanalyzer and showing everything from today. Here's the precipitation, and we can see it's raining up in the Arctic, the green, and then the blue is snow. So we've got precipitation, and look at all the rain over here on the east side. Here's Novaya Zemlya, it's raining over there, and that's why we can't get a real good view on NASA Worldview today, because it's so cloudy with all that precipitation, you know. So, so there's that. Let's look at the jet stream up there. It looks like a snake going up and down across there. The jet stream is awful. And then here's the sea ice and snow. I already showed that from today. And here's the sea surface temperature anomaly. Now this tells it all. Where you see the reds and the browns, the sea surface temperature is like 2 to 5 or 6 degrees Celsius higher than normal. It's even up in the white over here on the west side. You see that? In the white, in the Bering or the Beaufort Sea here.
What does that mean?
Where it's white.
Oh, that's
That
above.
means that's above the red. Where it's in the white, it's above the red. So
I've never
that's up
seen
to,
it before anywhere.
I know, me either. And this is from yesterday. They're always a day behind on sea surface temperature anomaly on here. So that's from yesterday. The others are from today. And look how red it is off the coast of North America and off the coast of Alaska. That's awful. That's awful. And then it's red up by Novaya Zemlya. So wherever you've got, and I just finished showing I was on the wrong model, but I showed the sea salinity, and I already showed that. I don't know if it was the right model or not. I can try and get that.
But also, I think yesterday on Worldview was quite indicative because I got a few screenshots and I showed some areas within within that kind of 80 to 90 degree north latitude where the ice is clearly breaking up.
Okay, I've got the right model here. Maybe I
Yeah.
had the right one and I just didn't know it. This is the GLB. That's the right one. Here's the sea surface sea surface. I mean the sea. This is the salt water. The salinity in salt water. You know, the red is the salt water, and the blue is the fresh water. So look at all the red coming in.
Yeah. So, can you hear me?
Yeah,
So the color chart on the side, is that percentage of salt salinity, is it?
I guess. I don't know. I haven't found a way to
No.
interpret this graph, but yeah, the redder you get, that's the more salinity, the more salt concentration in there. I think I saw a Paul Beckwith video where he talked about it, and so the higher it is, you know, on this chart, that's the higher it is in the saltwater concentration. And when it gets up into the black, that's 36, and we can see that down on
Hmm.
the southeast corner. That's in the Atlantic. So, is there anything else you want to look at on this one?
No, probably not. I mean, I think you covered. I mean, the two things that just blew my mind with the sea ice concentration and the sea ice thickness, and just the
Oh,
changes.
yeah. Let's look at the
Yeah.
here's the concentration. I saw that on your blog post and I was like, oh my gosh. So the concentration means how solid it is. And this includes extent. And so where you see the orange, it's more solid. And when it comes down into the yellow, it's 70, about 70% concentrated. And then when it gets into the green, it's 50 down to 40 and so forth. So I'll run their GIF for the sea ice concentration. So the concentration is going away real fast too. So by the end of their forecast period, it's not looking good. It's getting down into the blues and the greens at the end of the forecast period, which goes through the 24th. And we're losing concentration all the way across, even across right across the North Pole. So let's see what we've got here. Yeah, this GIF is wrong. It's only for 2 weeks. It's only for last week and then going once
Hmm.
and then goes forward. So, but it's still showing not very good. Not a good outlook.
Not.
So, is there something else you wanted to look at on NASA
Well,
Worldview?
yeah, I sort of really wanted to go back to this because uh, I know that certainly yesterday I was seeing some stuff. It was uh, there was a little bit less cloud, so maybe if we can identify those areas where there wasn't cloud. I think it was yesterday.
Yeah, I have it on yesterday, and we can see here on the west side. This is in the Beaufort Sea. There's clouds here, but you can see the sea
Oh.
ice, just chunks there.
But what really interested me was what was happening within the 80 degrees north latitude. There were areas where I could sort of
Okay.
definitely identify that ice was starting to break up.
Yeah,
Um,
well, it's already broken up on northern Greenland. Oh,
mhm.
look, and we can see here, see around the Canadian archipelago here. You see there?
Yeah.
We can see, uh,
The coordinates I've got, and these are approximate, were 105 degrees east and 85 degrees north. So if you can find that, that was up in the you know, the Laptev or somewhere like that, I think.
Okay, let's go up there. Oh, I wanted to show you something while we're here. You see this island? You see
Yeah,
this
that.
island here?
Yeah.
This is October Revolution Island, and this is home to about 5 or 6 ice caps. And this Volvolov ice cap right here, it's
Yeah.
melting so fast, and you can see the ice flowing into the
Wow.
ocean here. You see that? That's the
Yeah.
ice flowing from the ice cap into the ocean. You can see that really well with no clouds. It's a really good picture of it. But that's this ice around the island here is from that ice cap flowing in. Um, Here's a big open space. You see that? Is that what? That's at 102 and 77.
Yeah, this was 105, but it was halfway to the pole. It was at 85 degrees north. You know,
Okay.
that blew my mind.
Yeah.
And it was somewhere between. There's an island called Severne Ostrov or Zemlya, and the pole.
Here's some. Here it's
Yeah,
really bright.
yeah. That's probably it.
Is that
I know,
it?
but
Yeah.
that's 80 years. But even
That's
further,
80. Mm-hmm.
yeah, but there was stuff at 85. I mean, that's what blew my mind. And
Here.
it was somewhere on the edge of the cloud too. There was cloud, and
Mm-hmm.
then there was a clear area. That
Well, it's already,
might be it
yeah,
there.
it's melting in really far.
Yeah,
This is
yeah.
about
I mean, 85 degrees.
81.
Yeah,
So I'll just follow this in. Oh, wow. We can see it breaking up here. You see that?
yeah. I know.
Here's
Yeah,
some. Oh,
yeah.
is that it?
Yeah, well, it might be, yes. Depending on what latitude.
That's 84 and a half by 117.
Yeah, that would be it. Yes, that would be it.
Yeah.
And I think if you go over, you come out of the cloud, you can see it more clearly. If I'm right. Yeah, there.
Yeah. Here's some over here. Yeah. And some of these might be melt ponds too that are forming on the ice where the snow is melting. So yeah, this is dramatic.
And they must be pretty huge melt ponds if that's what they are.
Mm-hmm. So here's the North Pole where all the lines come together, and that's 90 degrees north latitude is the North Pole, just for people if they don't know that. So we can see it starting to break up here.
So do you think those are melt ponds that you just were looking at?
Some of them might be because it's maybe like where we see the darker thing here.
Yeah, well, that's
That
what I
could
was
be
thinking.
something like a melt pond.
I mean, it's not like this sort of, what you're looking at here, you know,
Well,
it's
it's
quite,
hard to, sometimes it's where it's solid like that, it's hard to tell the difference between the clouds and
I
the
get
ice.
it.
But we can see the edge here, looking through the clouds. The edge is right there. There's an edge of that's melted. Look at
Yeah, yeah,
that. You see
yeah, yeah,
that?
yeah,
That's
yeah,
86.
yeah,
That's
yeah.
at 86 and minus 102. So
So,
that is that long line. That's that long line. I'll show you what that is.
so that's
Um,
a melt pond on top of 2 meter
uh-oh.
thick ice.
Yeah.
I mean,
Well,
that,
it's melting. It's right. It's up here. We can see it. Yeah. There it is.
yeah.
Of course, we're looking through a little bit of clouds, but you can still see it. So, do you want to? What do you want to look at next? Anything else up here?
Um, no, probably not. I think we've covered the basis. So what really struck me was what was happening between, inside that line. I mean, we know that the
Mm-hmm.
ice destroyed outside of that line. Um, but maybe we have got the time to go on and look at the methane.
Sure. I've got methane up,
Yeah,
and then we've got a couple of articles to look at
yeah,
too. So this is CAMS, and this is new methane data that they just put up. This is from yesterday, and I haven't loaded up the movie yet. I'll open up my browser. Let's see if it'll load up or if I'm running too much. Here it goes. So this is the Arctic view surface level. And so what we're seeing high release still near Novaya Zemlya. We're also seeing yellow in the colors of the methane near Novaya Zemlya. That's, the methane goes from green to yellow when it's releasing more. So that's kind of the this is the first we're really seeing of the yellow coming up in the Arctic.
And then the thing is that if we still had the old color charts, we would be highly alarmed at what was happening there, in the north of the Bering Strait in eastern Siberia.
Right,
It's in green,
right.
but I don't know kind of what that translates to.
Yeah.
Can't see
Okay.
that.
Um, we're seeing also a huge release from Norway, Sweden, and Finland. And look at it, it's coming up into the Arctic. Now look at that. You see that? That's in the forecast period. It's still loading. We're seeing red come up there off the coast. Now, so the data is from Tuesday, and then the forecast runs Wednesday through Saturday. Now watch, see the big black stuff is coming out. And I don't know why that area is just covered with methane, but it is. It's just like China's covered with methane. Do
I
you
mean,
have
that's
any ideas? Do you have any ideas why that area
no,
is?
no. I've got no idea because I mean, Scandinavia is not highly industrialized like China, and I can understand that in northern Scandinavia, you might have some melting of permafrost. I don't know, but no explanation whatsoever.
It's awful. But I've been seeing that, because I look at this on a daily basis, and it's unreal right up there. I don't know if it's the permafrost or the ground, if it's mainly peat, which would have a lot of decaying stuff in it, and it's the middle of summer there, so I don't know. So that's what the methane is doing in the Arctic right now. Do you want to
And
look at? Hmm?
it did this last summer, didn't it, Margo? But then it sort of stopped in Scandinavia over the winter.
Yeah, it slowed down. It really
Yeah.
slowed down a
Oh,
lot. Hmm. Okay. Is there anything else you want to look at on methane here?
yeah. No, I think unless we just want to have quickly, look at,
Yeah,
at the 100
this
millim.
is yeah, this is our introduction show, and so, we don't have to do everything today. Um, where is your blog post? Here it is. You put this blog post up. Um, this is a brief update on ice thickness and volume from yesterday, and here's your video you made on it. And you've got some good articles linked here. Earth just had its hottest June on record, on track for warmest July. And this is important because of the Sam Carana post that we're going to look at too. This is from the Washington Post, and it says, boosted by history heat wave in Europe and unusually warm conditions across the Arctic and Eurasia, the average temperature of the planet soared to its highest level ever recorded in June. According to data released on Monday, July 16th by NASA, the global average temperature was 0.93 degrees Celsius above the June norm, based on a 1951 to 1980 baseline, easily breaking the previous June record of 0.82 degrees Celsius set in 2016 above the average. So that that's very bad news
Yeah.
for for everything. And they're saying that July is picking up, and it's going to pick up where June left off, and July is probably going to be the hottest one on record too. And so as a result, and I'm not going to read all of this, but as a result, what this means is more methane, more wilder storms. The jet stream is all messed up. There are going to be wilder storms. There's going to be more flooding. There's going to be more droughts. With the heat, there are going to be more heat waves and more deaths from that. And so this is the beginning of the catastrophic runaway climate change that Guy McPherson has been talking about. Would you agree?
Absolutely, yes.
Yeah. And then this is from Sam Carana. He put this up yesterday. Most important message ever. And I covered this in my show last night. And he says, a catastrophe of unimaginable proportions is unfolding. Life is disappearing from Earth, and runaway heating could destroy all life. At 5 degrees C heating, most life on Earth will have disappeared. When looking only at near-term human extinction, 3 degrees C will likely suffice. Study after study is showing the size of the threat, yet many people seem out to hide what we're facing. And so this image is from his blog post, When Will We Die? And he's showing that the possibility of us reaching the 3 degrees C increase by sometime next year, in the middle 2020. So, and then I was a little confused by his blog post because he says, where was it? It was, okay, I'm just going to go to his blog post and look at it from there. He says, the image confirms an earlier analysis that it could be 1.85 degrees Celsius or 3.33 degrees Fahrenheit hotter in 2019 than in 1750. So, and then he says, here it is, the NASA data, oh, he changed this. He changed this from last night. Yeah, he keeps editing. The long-term trend points at a 3 degrees Celsius rise by 2026. A 3 degrees Celsius rise could eventuate as early as 2020 in case of a persistently strengthening El Nino, etc. So when they talk about pre-industrial, what is the year for pre-industrial levels? What is the year? Is that 1750 or 18?
Well, I mean that's the whole contention, because I think they've been comparing it with, kind of, what is it, up to 1980, or 1950 to 1980,
Right.
And they seem to sort of, depending on the point that they want to make, they change the whole baseline. Whereas Guy and Sam have been arguing that you've got to measure from the 1750
right.
Baseline, and I think that they might have done that in the past, but then more recently they've changed the baseline to sort of 1950 or whatever it is, to try and kind of make it seem as though it's better than what it really is.
So we don't know what it is, really. We don't really know.
No. And then I noticed that Washington Post article said it's increased, what is it, by 0.8. Anyway, I mean, it didn't seem to agree with what Sam Karana is saying, but he hasn't actually provided a source for when he's saying that it's 2.18 or.
No, he just says June 2019 was 2.08 degrees Celsius warmer than the 1980 to 2050 annual global mean. That's
so
all
I'd like to know where
says.
he got that from, because it contradicts. It's contradicted by what the Washington Post is saying, and and he's talking about the 1980 to 2015 annual global mean. So it's not about the baseline,
Yeah. Well, it could be. He could be right in what he says there, but the way the Washington Post says it, they say it's the warmest June on record.
Yeah. So they're both saying the same. It's just that the numbers are different.
Oh, okay.
And I would love to know the score.
Okay.
They
say.
Say that,
Yeah, they say 0.93 degrees Celsius above the baseline of the June norm, above the June norm, based on 1951 to 1980 baseline. So that's the same as what Sam Curran is using.
Yeah. They come up with figures.
But Sam, I did the wrong thing. But Sam Carana says it's 2.08
Yeah.
higher. So I don't understand.
Anyway, it's a lot.
It's a lot, and it's a lot hotter than anybody it's expected, and so I think we can just suffice it to say that.
Yeah.
So, um, here's July on course to be hottest month ever, say climate scientists. And that's where you ended the blog. So, so it's not looking good. And then here's another article that we can just hit some highlights on. This was published in June of this year. This is from Natalia Shukova and her partner Igor Simolatov and how do you say Evgeny Shuvalin?
Evgeny
Oh,
Churilin.
okay, Evgeny Shuvalin. Okay, and this is, and if people don't know, Natalia Shukova is a Russian scientist, and she's the one that did the initial research on the melting permafrost or the hydrates in that are buried in the sediment of the Chukchi Sea of the East Siberia ice shelf, and saying that there's so much methane buried there, and that if it melted, we could get the 50 gigaton burst and all that. Am I right in what
Yep.
all I said? Okay. So she released another study or paper, Understanding the Permafrost Hydrate System and Associated Methane Releases in the East Siberian Arctic Shelf. And this was published June the 5th by Geosciences. And in the abstract says that this paper summarizes current understanding of the processes that determine the dynamics of the subsea permafrost hydrate system existing in the largest, shallowest shelf in the Arctic Ocean, the East Siberian Arctic Shelf, or the ESAS. We review key environmental factors and mechanisms that determine formation, current dynamics, and thermal state of subsea permafrost, mechanisms of its destabilization, and rates of its thawing. A full section of this paper is devoted to this topic. So it goes on, but they say the Arctic is warming dramatically, and they're looking at this certain area, and they're actually seeing that the seawater that goes in there and mixes in with these hydrates, it's making them melt faster.
Mm-hmm.
You're aware of that, right? And that makes sense. And so this study goes on and on and on, but they are very, very concerned about that Laptev Sea and that whole shallow area, and that there's the methane is melting so much faster, and that the thickness of the permafrost is so varied. It can be thin, it can be thick, and they just don't know. So, and here are the mechanisms. And this is a real detailed scientific report. And so for the scientists who want the in detail, all the I's dotted and T's crossed about what's going on, they can read this and it shows absolutely how it's melting faster, and they're very concerned. And let me see if I can find something to highlight. And they're saying increasing periods of open water implies an increasing number of storm events, when wind speed increases to greater than 15 ms-1 and the boundary between sea surface and air increases manyfold due to deep water mixing. Such events have the potential to rapidly ventilate bubble transported and dissolved CH4 or methane from the water column, producing high emission rates to the atmosphere. So in layman's terms, with the storms, the wind and everything, it can cause the water to come and release the methane faster. And we're going to have more and more storms up there too. And she says about 10% of the ESAS remains open water in winter. Did you know that? It it doesn't freeze. It remains open water in winter due to formation of flaw polynyas. These are formed simultaneously with landfast ice in November, and flaw polynyas propagate out of fast ice hundreds of kilometers north. The flaw polynyas provide pathways for CH4 escape to the atmosphere during the Arctic winter. So that's why we were seeing methane come up in the wintertime. We saw
Yeah,
that, remember? And we were flipping
yeah,
out.
yes,
It was
absolutely.
it was much worse coming up in the winter than it is right now. So that's why. It says areas of flaw polynyas in the ESAS increased dramatically by up to 5 times during the last decades and now exceed the total area of Siberian wetlands. This implies that the ESAS remains an active source of CH4 to the atmosphere year-round, even in the winter when terrestrial Arctic systems are dormant. So there you go.
So they're confirming their observations.
It confirms everything that we've seen.
Yeah.
And so let me just continue. This is good. Increasing storminess and rapid sea ice retreat causing increased CH4 fluxes from the ESAS are possibly new climate change driven processes. Continuing warming of the AO will strengthen these processes and the role of the ESAS as a year-round contributor to global CH4 emissions and will grow over time. And listen to this, the ESAS is a tectonically and seismically active area of the WO. During seismic events, a large amount of overpressurized gas can be delivered to the water column not only via existing gas migration pathways, but also through permafrost breaks that can occur within otherwise continuous permafrost or pingo-like structures observed on the Arctic shelf. So that's why I'm watching earthquakes. And
Yeah.
we see Arctic earthquakes all the time. So I thought that was very, very interesting.
And then Arctic News is very, quite interested. They report on the Arctic earthquakes as well. They obviously are significant.
And in this picture, there it is. Can you see that?
Yep.
It says distribution of sea org in the surface sediments of the world ocean. Blue dots mark the position of discovered or predicted hydrate deposits. So all those blue dots are, and it's all around the world, it's not just in the Arctic. They're showing where these huge hydrate deposits are.
Yeah. In the case of New Zealand, they've got the blue dot on the wrong side of the island.
Yeah. Yeah. Well, it's in the vicinity.
Yeah.
So anyway, how long have we been going? We've been going a while, right?
Yeah, I've got no idea actually.
Yeah. So people can certainly read this paper, and I will leave links below once this gets up on YouTube. Um, so in summary, she says that they need multi-level and multi-seasonal investigations that should be performed, aimed at quantifying different components of annual emissions and defining the factors controlling them. There are several flux components that await incorporating into the annual CH4 flux budget: flux during ice breakup, flux during deep fall convection, flux during storm events, flux during winter polyunus, non-gradual flux by strong ebullition caused by mass wasting, seismic tectonic events, and sediment settlement adjustment caused by releases of preformed gas from seabed deposits and different types of hydrates. Because it comes from all these different places, and so all those things have to be studied. And, I don't know if they're going to have time to study them.
Yeah, that's right. Can I just make a point?
Yeah,
Uh,
yeah,
it goes back to what we were discussing before, about the ice and that chap, Comrades. He had a split screen and he was able
right.
to show
Mm-hmm.
2012 yeah, and then apart from the fact that it looked, to me as though actually this year was far worse than it was in 2012. The ice was in much better shape back then, but it took this huge mega cyclone to change that. Now, I thought that was hugely significant, really.
Mm-hmm. Well, I can set up a split screen here. Do you want to look at last year?
Uh, yeah, could do. Yes. Oh, yes. See, I never realized that you could do this.
Yeah. It says I'm in comparison mode now. They've got
Right.
a big black square from last year. There it was on July the 9th.
Yeah.
Well, the problem is with the clouds,
Yeah,
it's hard
yeah,
to,
exactly. It takes a whole video to go through and analyze it as he did, because you got to go backwards and forwards.
yeah. It looks thinner to me this year.
I'm looking at Svalbard as you're going backwards and forwards. It's amazing the difference.
Mm-hmm. Yeah,
Oh, wait a minute.
definitely. You
That
can
was
definitely,
yeah,
you can see the difference in the thickness because it looks darker, much darker this year.
yeah, yeah,
I don't know if that's because we're looking through some sulfur dioxide or if it's just that much thinner. It could just be that much thinner. I think it
yeah.
is. So we can change the year. We can go back. Here's
Oh,
2017. Oh, you can see a huge difference there. See that? See how far it goes out on
yeah, yeah,
2017 on the right? It's easier to see if you go fast. See?
yeah, yeah.
Yeah, it's already melted in a lot on that east side.
Mm.
But that's how you do the comparison. And you choose which one you're going to look at, which one you're going to change up over here.
So how did you get into comparison mode, if I can ask? I mean,
Right
if you
down
don't mind.
here, it says start comparison. See,
Oh,
from
okay.
right there.
Yes. Okay.
And then you set up, it compares from the screen that you were on, and then you
So,
click, and then you can change the date there.
yeah, yeah.
All right.
That's brilliant.
And then you've got A and B listed down here beneath the arrows. So that's how that works. All right. So, well, it's 4:21 my time. We've been at this a while.
Yeah, I think we've covered the bases. I mean, we're going to
Yeah,
have to do it again.
yeah, I think we've done a good overview, um, just to kind of get back in the swing of things. So we'll go back to here we are today. So let me get back over to TalkShoe. Well, thanks for hanging in there and helping me work out the kinks on this, and maybe it'll be okay for us to use this next time now that we've kind of gotten back in the swing of things.
Yeah, it's been quite a
So
process getting here.
it, it's been a process. So I'd like to thank everyone for joining us, and remember the time is short, and I recommend everyone get your spiritual house in order because no one knows the day or the hour. So until next time, God bless everyone and go in peace, and we'll talk to you soon. Goodbye.